Hi, welcome back to the second part of 2.2 R13. In this one we're just going to do some examples and I'm going to go through them pretty quickly. So it would be good if you could give your attempt to these questions before you watch the rest of this video. Alright, so the first question says find the x-intercepts of y equals x squared minus 25. And if you look lower on the bottom, it also says sketch the graphs of 1 and 2, so I'm just going to do it all at once. Okay, so in order to find the x-intercepts, we have to set y equal to 0 and solve for x. And you're going to notice this is a difference of squares question, so we're going to factor it out, and this is what we are going to end up with for that one. Okay. Now, a quick sketch of the x-intercepts are right here. I've also labeled the y-intercept. It's not to scale, but I've labeled what my scale is, so that should be good. And I've noted that this is 1 over here. Now, in order to sketch the graph of the square root of x squared minus 25, I want to plot my invariant points at 0 and 1. And then I'm going to connect the two with a curve going above the line, and then I'm going to continue on my sideways line parabola like so. In order to draw the next one properly, I'm going to have to either move myself or move my paper, just because it's easier to draw the parabola that way. And then I'm going to have my sketch like that. So in the blue ink you see here and here, this is my square root of x squared minus 25. Okay, now in this next question, I've got x squared plus 3. And I've taken the liberty of sketching what x squared plus 3 looks like. You're going to notice it's a parabola shifted up 3 units, and there are no x-intercepts. So this has no x-intercepts. Alright, now the square root of it is going to be, it's going to be like the wider kind of parabola looking thing. So here this is 3, so this point is going to end up being at root 3, and root 3 is somewhere around 1.7-ish. So we can just plot that point somewhere right here, just above the 1.5 mark, and call that square root 3. And my parabola is going to be wider, and it's going to kind of go like that. Alright, so that is our y equals square root of x squared plus 3. Okay, so we're just doing quick sketches of them. Now here, this is the answer to question 4 and 5. So right here I've set it y equal to 0, and I've solved for x, and you can see that you end up with 2 x-intercepts. And if we were to look at the sketch of this, of the original, then it would be the upside down parabola like that. And then if I were to do the square root, I would have to take the square root of 32, drop it down, get my invariant points for 0 and 1 here, and then kind of make a circle, half circle kind of looking thing. Okay. Number 4, my square roots, I set y equal to 0 and then I solve for x, and my answer ends up being plus or minus square root of 10. And this ends up being a parabola that kind of looks like that. Okay, with my y-intercept way at 50. And then if I were to draw the square root, I would again set my y equals, where y equals 0 and 1, y equals 0 and 1, and then draw my half-looking parabola on either side. Okay, so why is it important to determine the x-intercepts? Well, one of the reasons it's where y equals 0, and that's one of the invariant points that you get. Alright, so on to the next page. We're going to look at how to sketch the graph of these following functions. This we're going to use the parent function square root of x, and use those points. So here, that's kind of your first point where the original graph would be. And you want to reflect over the x-axis. So the 0, 0 stays there. This ends up here, and this ends up here. We reflect. Then because of this 2 right here, everything is going to be multiplied. All the x values are going to be multiplied by a half. So this actually comes in here. This point comes in here. And then we can connect these the 0, 0, those 3 points together. And we end up with our graph looking like that. All right. Now this one here, this is the square root of x, and it is clearly just shifted up 3 units. So the original points would be here. Well, that's a bit of a glare. Let's see if I can fix that. Okay. Ooh, too much lighting. Okay, so the original x squared graph would be here, here, and here. Those are 3 of the points. So this is x squared, this is the square root x right here, here, and here. That would be the original. Now we see that this is the square root of x shifted up 3 units. So we're going to take this point, go up 3, take this point, go up 3 units to 1, 4, and then take this 4, 2, and it'll end up at 4, 5. So then these are going to be, our graph is going to look like that up here. All right. You can see the domain and range are already stated for both questions. And let's have a look at C. Okay, so for part C, I've already factored it here for you so that you can see the transformations that can be done on the square root of x. We're going to multiply all the x values by a half, and then we're going to shift everything right over by 2 units. So this is where the original will be here, here, and here. And then the next thing we do is we take everything and we divide it by 2. So all the x values you want to divide by 2. So this will end up here. And then we're going to take all of these and we're going to go right 2 units. So we're going to go from here all the way here. From here 2 units. So make sure you're going 2 full units because we're on the half mark there. And then this over here to 2 units. So this, so I need to make this a nice curve. Okay, make sure you don't have a straight line here. Make a nice curve there. Okay, so there's the domain and range for part C. All right, part D. Now this, whenever you have an x squared underneath the square root, and there's more stuff here, you want to graph y equals whatever's underneath the square root first, and then use the invariant points of where y is 0 and 1, and then do your sketch from there. So make sure you go up between the 0 and 1 and have your sketch go like that. Okay, and then I'm going to turn this around to get a nicer drawing. So I want to go above my, between where my y's are 0 and 1, and do my sketch like that. You notice here they're not quite even, so try to make them as even as possible. Okay, and there is my domain. So you can see that anything here, this is going to be the square root of 3, and it's going to get bigger from here, and then this is going to be the square root of 3 negative over here, so then that's going to get bigger over there. All right. Now E and F, note here that 2x minus 4 is a straight line, and then we've square rooted it. So what I want you to do for this one is something a little different. Graph the 2x minus 4, and then have your invariant points at y equals 0, y equals 1. And then this is going to end up being actually at 2, because if you have x equals 4, you put that in there, you end up getting 2 out of that function there. So that's what the sketch looks like. Okay, And for F, same idea. So graph x plus 1 as the dotted line, and then go between the 0 and y equals 0 and y equals 1, and then connect those dots. And this also ends up being, if you plug in the x equals 3, plug in x equals 3 here, what do you get? 3 plus 1 square root, that's 4. So square root of 4 is 2, so that ends up being right on the 2. Okay. Now for the last page, I want you to sketch the graph of square root of negative x plus 1 all squared plus 4. That's all underneath the square root. You're given the graph of the associated parabola here. So now all you have to do is find the invariant points at 0, y equals 0, and y equals 1. And then right here, note how this is y equals 4. Just take the square root of that, and that'll give you this point here, so just go directly down. Now between the 0 and 1 again, make sure you go above, and try to keep this as nice as you can. I'm wondering if you can actually hear my kids upstairs. My daughter's playing the recorder now. Awesome. Now if you're lucky, she'll come downstairs and actually play for you. Okay. So that's what that ends up looking like. So you can see it's a parabola going this way and then a parabola going that way. And now here, uh-oh, my son's coming down. So this is your x squared plus 2. It's a parabola shifted up 2 units. And then we're going to have our vertex here. It's going to be the... No, just wait, sweetie. We're going to have... Just wait a second. It's going to go from here down, and then see how this is 3? This is going to be the square root of 3. Okay, so then we're just going to connect those dots, make it go up like that, and it's going to be kind of like a little wider bit of a parabola.
Please stop.
Now, do you want to say hi?
Hi.
You want to tell everyone, make sure you do your homework?
I want to do my homework.
You want to do your homework?
Okay, this one.
Okay, just wait.
Okay, I want to do my homework.
Okay, sweetie, just a
Can
second.
I put music on for homework?
Sure, you could play some music. Now, I want you guys to try this here, extra practice. Make sure you do it. And I've just kind of drawn, this is how I think these through. I kind of draw a little crosshatch of where it overlaps this area and this area. Okay? So, I hope you had fun on that one, and we'll see you soon. Oh, now here comes the music.